everyone to another video of making math easy for better understanding. Still, this is your teacher Hazel, and for today's video, we will discuss about partial fraction decomposition and repeating linear factors. And now, since our lesson for today is about partial fraction decomposition and repeated linear factors, let us first define what is linear factors. So, linear factors or linear equation are the first degree equations that are the building blocks of more complex and higher order polynomials. Let us also remember that linear factors appear in the form of ax plus b and cannot be factored further. So, a repeating linear factor occurs if a linear factor ax plus b occurs p times of the factor of the denominator of the given fraction. So, meaning a certain linear factor or a certain linear equation would occur p times or would occur 2 or more times as a factor of the denominator of a given fraction. So, it then will correspond to this factor will associate the p partial fraction. So we have here two examples. So the first example is 5x minus 7 all over the quantity of x minus 1 raised to the power of 3, meaning x minus 1 would occur 3 times as a factor of the denominator. So we will get its partial fraction as a over x minus 1, which is the linear factor. So in each partial fraction, we will just increase the exponent of the denominator from 1 to 2 to 3. So we will just increase one at a time. So that gives us a partial fraction of a over x minus 1, which is raised to 1, plus b all over the quantity of x minus 1 raised to the power of 2, then plus c all over x minus 1 raised to the power of 3. This one would also be applied to the second equation, which is x squared all over the quantity of x minus 2 multiplied to the quantity of x minus 3 squared. So, as you can see, only the quantity of x minus 3 was repeated. So, we would equate this to a over the first factor, which is x minus 2, plus b all over x minus 3, which is raised to the power of 1, plus c over x minus 3 raised to the power of 2. So, still, the rule apply on the second equation. Now, let us have an example. So, the first example in the previous slide is 5x minus 7 all over the quantity of x minus 1 raised to the power of 3. So, just like what we did on the previous slide, we equate this equation to the partial fraction which has a increasing power of the denominator. So we equate this to a over x minus 1, which is to the power of 1, plus b over the quantity of x minus 1 to the power of 2, plus c over x minus 1 to the power of 3. So as you can see, their exponent from a to c is increased by 1. So the first equation is the first denominator is in the power of 1, then the second one is in the power of 2, and then in the third one is in the power of 3. So to find the values of a, b, and c, we will just multiply the whole equation to their LCD or least common denominator, which is the quantity of x minus 1 raised to the power of 3. So to solve, we will multiply their LCD to the numerator, then divide it to the denominator. So that gives us 5x minus 7 multiplied to the quantity of x minus 1 raised to the power of 3 all over x minus 1 to the power of 3. then a times the LCD x minus 1, or the quantity of x minus 1 to the power of 3 over x minus 1, plus b times the LCD, which is x minus 1 to the power of 3 over x minus 1 to the power of 2, plus c times still the LCD, which is the quantity of x minus 1 over 3 all over x minus 1 to the power of 3. So just cancel out common terms, or so that gives us 5x minus 7 equals a times the quantity of x minus 1 raised to the power of 2 plus b times the quantity of x minus 1 plus c. So expanding the squared equation, which is x minus 1 raised to the power of 2, gives us 5x minus 7 equals a times the quantity of x squared minus 2x plus 1 plus b times the quantity of x minus 1, so that gives us bx minus b plus c. Then distribute a to the quantity of x squared minus 2x plus 1 gives us ax squared, which is a times a x squared minus a2x plus a, which is a times 1, plus bx minus b plus c. So just copy the previous one. Then let us combine like terms. That gives us 5x minus 7 equals ax squared minus a2x plus bx plus c minus b plus a. So since the left side of the equation does not have values for x squared, since it is only a linear equation, so we would equate the coefficient of x squared on the right to 0. So first, let us factor out the equation a 2x plus b. So that gives us a2 plus b times x. So just what I have said earlier, the coefficient of x squared on the right side of the equation would be equate to 0. So that gives us a to 0, then to 0, and then the coefficient of x would be equate to the coefficient of x on the left side. So that would gives us a2 plus b equals 5. And then the constants on the right, which is c minus b plus a, would be also equated to the constant on the left side, which with what that would be negative 7. And now we have our three systems of equation, which is a equals 0, to a plus b equals 5, c minus b plus a equals 7. So since we already have our value for a, just substitute this value to the second equation, which is to a plus b equals 5. So just substitute 0 to the a on the second equation. So that gives us 2 times 0 plus b equals 5. So 2 times 0 would be 0. So that gives us b equals 5. So since we already have our values for a, which is 0, and b is 5, substitute these values to the third equation to find the value of c. So that gives us c minus 5 plus 0 equals 7. That be c minus 5 equals 7. And then using additive inverse, let us move negative 5 to the right side of equation. That gives us c equals 7 plus 5, and then c equals 12. So now we have our values for a, b, and c. So we can already find out or get our partial fraction for 5x minus 7 all over x minus 1 raised to the power of 3. So that gives us the value of a, which is 0, over x minus 1 plus b, which is 5, over the quantity of x minus 1 raised to the power of 2 plus c, which is 12, over the quantity of x minus 1 raised to the power of 3. So since the first equation would be equated to 0, so that gives us our partial answer as 5x minus 7 all over the quantity of x minus 1 raised to the power of 3 to 5 over all over the quantity of x minus 1 raised to the power of 2 plus 12 all over the quantity of x minus 1 raised to the power of 3. So that's now your answer. And now let us have another example, which is x squared over the quantity of x minus 2 multiplied to the quantity of x minus 3 raised to the power of 2. So as you can see, only the factor which is the quantity of x minus 3 was repeated. So we will have its partial fraction as a over the first factor, which is x minus 2, plus b over the second factor, which is x minus 3, but we will raise it to the power of 1. Then plus c over x minus 3 raised to the power of 2. So as you can see, since x minus 3 is the factor that is repeated, so we will apply the increasing exponent to x minus 3 only. Then to find the values of a, b, and c, we'll find the LCD and then multiply it to the numerators and then divide it to their denominators. So we will get x squared multiplied to the LCD, which is the quantity of x minus 2 multiplied to the quantity of x minus 3 squared, over the denominator, which is the quantity of x minus 2 times the quantity of x minus 3 squared. So that would be equal to a times the LCD over x minus 2 plus b times the LCD over x minus 3. And then c times the LCD over all over the quantity of x minus 3 squared. So let us just cancel out common terms, so to find the values of a, b, and c. So that leaves us with x squared equals a times the quantity of x minus 3 squared plus b times the quantity of x minus 2 times x minus 3 plus c times the quantity of x minus 2. So as you can see, we expanded x minus 3 squared, and then that gives us x squared minus 6x plus 9. Then multiply the quantity of x minus 2 to the quantity of x minus 3. So that gives us x squared minus 5x plus 6. So then we distribute a to the quantity of x squared minus 6x plus 9. So that gives us x squared equals ax squared minus a 6x plus 9a plus that we will also distribute b to the quantity of x squared minus 5x plus 6. So that gives us bx squared minus 5xb, or we could also write it as b5x plus 6b. Then also distribute c to the quantity of x minus 2, so that gives us cx minus 2 minus 2c. And then let us combine like terms, so that gives us x squared equals ax squared plus bx squared minus ax minus b5x plus cx plus 9a plus b6b minus 2c. And then after that, we will factor out ax squared plus bx. So that gives us x squared times the quantity of a plus b. Then also factor out negative a6x minus b5x plus cx. So that gives us a times the quantity of 6a minus 5b plus c plus the quantity of 9a plus 6b minus 2c. So as you can see on our left side of equation, we have only the x squared. So we don't have values for linear and constant. So the values for linear would be just zeros and constant. So we will equate the coefficient of x squared on the left side to the coefficient on the right side. So that gives us a plus b equals 1. And then the coefficient of linear and the coefficient of constant would be 0. So we will just equate it to 0. And now here is our three systems of equation, which is a plus b equals 1, which is the first equation from our coefficient of quadratic. And then the coefficient of linear will be on our second equation, which is negative 6a minus 5b plus c, and then the constant, which is 9a plus 6b minus 2c equals 0. So to find the value of a, let us just use additive inverse property. So just move b to the right side of the equation, so that gives us the value of a, which is negative b plus 1. Then let us substitute the value of a on the second equation. So that gives us negative 6 times the quantity of negative b plus 1 minus 5b plus c equals 0. So distribute negative 6 to the quantity of negative b plus 1. That gives us 6b minus 6 minus 5b plus c. So combining like terms, let us combine terms with the same variable, which is b. So 6 minus 5, that leaves us with b. So that gives us b plus c minus 6 equals 0. To find the values, so we could use additive inverse property. So we could move negative 6 to the right side of the equation, so that leaves us with b plus c equals 6. So since we are finding for the value of c, so that we could substitute it to the third variable. So we will just move again b to the right side of the equation using additive inverse property. So that leaves us with c equals negative b plus 6. So now we already have values for a and c. We could substitute these values on the third equation, which is 9a plus 6b minus 2c. So that gives us with 9 times the quantity of negative b plus 1 plus 6b minus 2 times the quantity of b plus 6 equals 0. Now let us distribute 9 to negative b plus 1, so that leaves us with negative b plus 9 plus 6b. Then distribute again negative 2 to negative b plus 6, so that would be positive 2b minus 12 equals 0. So let us combine like terms. Negative 9 plus 6b would be negative 3. So plus 2b, that leaves us with negative b. Then minus 3. So that is from negative 12 plus 9. So that leaves us with Using additive inverse property, move negative 3 on the right side. So that would be negative b equals 3. So divide by negative 1 both sides. So that would be b equals negative 3. Since we already have our value for b, let us substitute this value in the first equation so that we will get the value of a. So this we will get a minus 3 equals 1. Using additive inverse property, move negative 3 to the right side of the equation. That would be 3 plus 1. And then we will get the value of a, which is 4. Having the values for a and b, let us solve for c using the second equation, which is negative 6x minus 5b plus c. So just substitute the values of a and b to get c. So negative 6 times the value of a, which is 4, plus minus 5 times the value of b, which is negative 3 plus c. Negative 6 times 4, that would be negative 24. Negative 5 times negative 3, that would be positive 15, plus c equals 0. Negative 24 plus 15, that would be negative 9, plus c equals 0. Then using additive inverse property, move negative 9 to the right side. So that would be c equals 9. So we now have our values for a, b, and c. Since we already have our values, we can now get the partial fraction of our equation x squared over the quantity of x minus 2 times the quantity of x minus 3 raised to the power of 2, or x minus 3 squared. So the value of a, 4 all over x minus 2, which is the first factor, plus negative 3 over x minus 3 plus 9 over the quantity of x minus 3 squared. So now that is your answer. And that ends our video. I hope that you've learned something in today's video. Don't forget to like, comment, and hit the notification bell for more updates. See you in my next video.